Hello. Today we are going to look at finding distances on a dot grid. This is something that you will actually be using a bit more in your geometry class in the future when you do some high school geometry. So today we're going to look at how can we use the Pythagorean theorem to find the distance between any 2 points on a dot grid. So in front of me here, and hopefully in front of you as well, you have the lab sheet for lesson 3.3. You should see a dot grid and you should see 6 points on that dot grid. So the first thing we're going to do, let me pull up my draw pencil here. So the first thing we're going to do is we're going to look at KL. And we're going to make KL our hypotenuse. So this is my hypotenuse, which is going to be directly across from my 90-degree angle. So that means I have to drop it down this way and drop it across this way. I could have, if I had wanted to, made the exact same triangle going this way, okay? So it really doesn't matter which way you make it as long as you're understanding that KL is the hypotenuse. So I can see here that this is a side length of 2. Now, very important that you keep in mind it's a side length. We're counting the dots, we're counting the spaces between the dots. So this one is 1, 2, 5, a side length of 5. Okay, so we've got a side length of 2 and a side length of 5. But now remember, Pythagoras and the Pythagorean theorem says that a squared plus b squared equals c squared, and c is our hypotenuse. So we have to think about what would the square look like that's coming off of this side. That's 2. Well, 2 times 2 is 4. So the square that comes off the side of 2 would be 4. The square that comes off the side of 5 would be 25. So 4 plus 25 is 29. So what do I know so far? I know that c squared is 29. But I'm not interested in c squared. I'm not interested in that square that comes off of c. I'm interested in what the value of c is. I want to know how long is that actual hypotenuse. So I can find the square root of c squared, which is c, and the square root of 29. Well, I know that the square root of 25 is 5, and the square root of 36 is 6. So I know 29 is going to be somewhere between 5 and 6, and it's going to be a little bit more than 5. So I can use my calculator, and I can find the square root of 29. And I'm going to go to the tenths place. So when I look at my calculator, I get 5 and 38 hundredths. So we're going to say it's 5 and 4 tenths. So the value of c is 5 and 4 tenths, or the square root of 29. All right, I would like you to go ahead and find the length of MN and PQ. Go ahead. You'll want to pause here. We will talk about how to finish this up here in just a few moments. The next piece that I want to address is the fact that I can tell, remember the Pythagorean theorem has to do with right triangles. And I can tell I have a right triangle if my a squared, or my leg square, plus my leg square equals my hypotenuse square. So if I were to give you some numbers and say to you, do these make a right triangle? We've practiced this a little bit before. So if I said to you, I've got these sides, a 5, a 12, and a 13. So obviously the two shorter sides are the legs, the longer side is the hypotenuse. So I'm going to find the square that would sit on here. Well, a 5 square is 25. A 12 square is 144. And a 13 square is 169. So now my job is I have to decide, are these truly equal or are they not equal to one another? So I add up 25 plus 144. It is 169. So yes, this would make a right triangle. So now what if I said to you this, a side of 1, a side of 2, and a side of 4? Well, 1 squared is 1, 2 squared is 4, and 4 squared is 16. These do not equal one another, so I would say no. They do not make a right triangle. All right, your task now is to fill in this chart. You will simply go in just like we did here. You'll say 25 plus 144 equals 169, and we say yes. Good luck.